Okay, everyone, welcome back to our statistics class notes. We're now moving into section 9.3 in chapter 9. Remember, chapter 9 is about doing inferential statistics about population means. And in section 9.3, we're actually going to try and learn how to construct and interpret a confidence interval for a population mean. And in that process, we also need to be able to find the standard error of the sampling distribution of the sample mean. So the title of this section is Answering Questions about the Mean of a Population. So there's two approaches for answering questions about a population mean. These are exactly like what we did for a population proportion. We have confidence intervals and hypothesis tests. So for confidence intervals, these are used for estimating parameter values by finding a range of plausible values for it. So for example, for the population mean, remember the symbol for the population mean is mu, we're going to find a confidence interval for it, which will estimate that. Now we can't get it exactly, so we're going to have a range of values, a range of plausible values for it, where we'll be 95% or 99% confident or 90% confident, whatever we choose. But that's pretty confident that we have a range of plausible values for the true population mean. And then in section 9.4, we'll talk about hypothesis tests a little more. Okay, so I mean hypothesis tests. And remember, hypothesis tests are used for deciding whether parameters, in this chapter, that parameter, again, the population mean, value is one specific value or perhaps another that is either not equal to that value, less than that value, or greater than that value. So note, as mentioned above, these are the same methods as introduced in chapters 7 and 8, but modified to work now with population means. So, confidence interval. 1, it provides a range of plausible values for the population mean, and it also gives us a measure of the uncertainty in our estimate. So when we say we're 95% confident, etc., etc. Now the measure of uncertainty in our estimate gets better with a higher confidence level. That confidence level is when you say we are 95% or 99%. That's the confidence level. Confidence intervals should be used when you're estimating the value of a population parameter. In the case of this section of notes, the population mean, again, which has a symbol mu, on the basis of a random sample, right? We're taking a random sample and trying to estimate the population mean. So note, do not use a confidence interval if there is no uncertainty in your estimate. For example, if you're working with an entire population, if you happen to have the data for an entire population, that population is small enough, like all NBA basketball players or something that we can manage, we have all their data, then we don't need to find a confidence interval since the population parameter is known. There is no need to estimate it. All right, now the conditions to be met before constructing a confidence interval, these rely on the central limit theorem for means. So there's 3 conditions, and they're very similar to what we learned in previous sections in chapter 7 and 8, but we talked about this already in the previous sections of chapter 9. So 1, we have a random and independent sample. 2, we have to have a large sample. Now for the central limit theorem for means, again, that means that either the population is normally distributed, which means no matter what size sample, we're good to go. Now, typically we won't know if the population is normally distributed, so the sample size is at least 25. That means we have a large enough sample. And then, of course, we also need a big population, which means that it needs to be at least 10 times larger than the sample size because we're going to be doing our sampling without replacement. We don't want to ask this. We don't want to get the same data from the same person, or we don't want to accidentally have some independence brought in there either. So we have to be careful about that. But anyways, 10 times larger than the sample size is a good big population.